नमस्कार साथियों। सबसे पहले तो आज 15 अगस्त 2025 को 79 उन्नीसवां 79 है ना, स्वतंत्रता दिवस की सभी को शुभकामनाएं, है ना। नाउ आज हम लोग बात करेंगे, एक बहुत इंपॉर्टेंट थ्योरम है जिसका नाम है कैंटर्स इंटरसेक्शन थ्योरम, एंड देन वी विल डिस्कस nested interval theorem, which is the basically corollary of this important theorem. So बिना समय गवाए हम लोग बात करेंगे. So first there are few definition will be used. So we try to discuss one by one definition. So first is the convergence of sequence. So might be you are aware about the convergence of sequence in real number. Idea is the parallel. Only difference that is in metric space, if a d of xy is replaced by mod of x minus y, and in place of non-empty set x, if we take set of real number, so this result will be converted to the result from the metric space to the real space. So first we take xtba any metric space. We take sequence an. The n belongs come to the from x, and we say it converges to a some point a belongs to x if for any epsilon greater than 0 we are able to find some positive integer m such that d of an comma a less than epsilon. D means distance of an comma a less than epsilon for all n is greater or equal to m. It means after finite number of term, all the terms going to closer and closer to the a. It means their difference, their distance from a is become closer and closer, which is equivalent to distance between a and a tending to 0 as a tending to n tending to infinity. Means a1, a2, a3, and so on an. See, in sequence there are infinite number of term. So its convergence means, suppose finite term we can say, no, no. Suppose our sequence is what? 1 by n. If somebody asks what is the 100 term, you can say 1 by 100. But what what is the term at infinity? So infinity just realization the number is a very big. So if in some time we reach at infinity, so what term become? This is the meaning of the convergence. So, and if we try to write the same definition in the terms of open sphere, so what is the open sphere? If you take any open sphere, epsilon s epsilon a means center at a and radius epsilon, so we are able to find some positive integer such that the term of the sequence of mth and after mth term all should lies in the s epsilon a. Means an should belongs to s epsilon a for all n is greater than m. And if the an converges to a, we will write like that, or limit n tend to infinity an is equal to a. If I will say the in a simple way, what if sequence is given, what is an infinity term? Infinity वाला term कौन सा होगा? So since infinity is not fixed, so we can just take the idea of the infinity term. So this is the meaning of the convergence. And another definition is that is the Cauchy sequence. So here similar result is parallel. I mean definition is parallel, slight difference. So if you take any sequence an, so it is said to be Cauchy sequence if for given any epsilon greater than 0, we are able to find a positive integer and not such that distance between any two term of the sequence after some finite number of terms. Means n and m should be greater or equal to 0, then their distance should be less than epsilon. Means if xn is a Cauchy sequence, so after some finite number of terms, might be x and naught, all the terms difference is being the closer and closer and closer. Means whatever you choose epsilon, you can find such and naught such that distance between these two terms are very small, and when these two terms tend to infinity, its distance is 0. This is Cauchy sequence. Here I have not mentioned, but in the metric space, if a sequence is convergent, it is Cauchy. But converse is not in general metric space. But if you go to the real analysis, it means if you take d is equal to mod, I mean d of xy is equal to mod of x minus y, and x is equal to r, then both become equivalent. So in metric space, convergent sequence implied Cauchy, but converse is not true. But in real, both are the equivalent. So this is the very important result of the metric space. Now come to the complete metric space. So suppose some sequence is given and it converges to some point. It is guaranteed it will belong to the space? No. It may go outside. Like as for example, we take 1 plus 1 by n. If you take an is equal to 1 plus 1 by n and power 1 by n. This sequence term belongs to the Q, set of rational number. If you take n is equal to 1, it will become 1 plus 1 by, means here a1 becomes the 1 plus 1 by n power n is 2. If you take a2, it becomes 1 plus 1 by 2 and whole square. Means 3 by 2 square means 9 by 4. So all the term of this sequence is rational number, but the scenario is different. When you take n tend to infinite, so for this n tend to infinite, you know this limit becomes e. This become e. Okay, 1 plus 1 by n to the power n. This term become e, and which does not belongs to the Q. This so not necessary. All the when the point converging point belong to the same space. So if it's belong, then we call it the complete metric space. Like as real line. In the real line, if we take metric as usual metric, this mod, it is the complete. So we know real line with mod is a complete metric space. Now come to the statement. This is a very important theorem. So first we have to take metric space that should be complete. And now we consider Fn, this is the closed subset of X, non-empty, as well as this is the decreasing. Decreasing means which one is F1, F2, F3. So sequence is decreasing. Decreasing means first is the superset of second, second is the superset of third, mean the set is going to the smaller a smaller. Smaller means it is the subset of the previous one. And distance of not the distance, is the diameter. If the diameter of Fn as n tend to infinity, means similarly if you take n Fn and n tend to infinity, and we assume its diameter is means what? If the diameter of any subset is that, if you take any set, if you take any set and x y, take any arbitrary element of that set, right? Take the distance of this and then take the supremum. This is become the basically the diameter of A, right? So diameter of any set is the maximum distance or ये कह दो supremum distance of any 2 points of that set. Okay, so if diameter is tending to 0, then if you take arbitrary intersection of each fn, then it contain exactly 1 point. This is the statement. Now we try to prove. Since we have assumed fn is non-empty for each n, so at least one element belongs to each fn. So I am taking x1 belongs to f1, x2 belongs to f2, x3 belongs to f3. So in each fn there is at least one element, since each element is non-empty. So now by that we will construct a sequence. Which sequence? We construct x1, x2 and so on. So x1 is coming from f1, x2 is coming from f2 and so on, like that. Since each fn is non-empty, so we can take at least one element. Now we show that whatever the sequence we have constructed, this is the Cauchy sequence. So we want to prove the Cauchy sequence, then we have to prove distance of xn comma xm is tending to 0 as m comma n tending to infinity, or distance between xm xn less than epsilon for all m comma n is greater or equal to n naught. So let's try to prove. Since by assumption fn is decreasing sequence, so obviously fn plus 1 will be the subset of fn for all n, and therefore xn plus 1 xn all lies fn. Why? Because xn belongs to fn, xn belongs to fn because we have constructed the sequence that set, and xn plus 1 belongs to fn plus 1, but fn plus 1 is subset at what? Fn. So xn plus 1 also belongs to fn. Similarly, an forward term of the sequence means xn plus 2. Xn plus 2 coming from where? This is coming from the fn plus 2, and fn plus 2 is subset of fn plus 1, and fn plus 1 is subset of fn, since these are the decreasing sequence of closed subset. So xn plus 2 also belongs to the fn, and term beyond that, xn plus 3, xn plus 4 all belongs to what? Fn. Now it is given that diameter of fn tends to 0. It means as n tends to infinity, it means for given epsilon greater than 0, we are able to find some n naught such that d of fn is less than epsilon for all n greater or equal to n. D of fn tending to 0 as n tends to infinity means as n is increasing, f1 diameter is bigger, f2 become smaller, n smaller, then smaller, then smaller, and it is realized as n tends to infinity. Uh, this tending to 0, it means the fn going to become smaller and smaller. So if we fix some positive real number epsilon greater than 0, so definitely we are able to find some n naught such that this diameter of all fn where n is greater or equal to n naught is less than epsilon. And if you take n is equal to n naught, then by previous this one, xn naught plus 1 all lies between what? Fn naught. Thus, by the previous observation, we are able to find two positive integer m and naught such that d of xn comma xm means this is the d, this is the what? Distance, because 2 points we are talking about the distance, and this is nothing but this is the diameter. So assumption is, notation is the same, but be careful about that. For set we are talking about diameter, for 2 point we are talking about the distance. So we know since xn and xm both belongs to dafn, both belongs to fn, xm and xm both belongs to fn naught. Why? Because we are taking m and naught greater or equal to m and n is greater or equal to n naught. So m and n naught should possible values what? Either n naught, either n naught plus 1, either n naught plus 2. And by previous uh, slide we have already shown these all belongs to fn, and its diameter is less than epsilon. and we know diameter is the maximum distance. So distance between these 2 points is always less than the distance of that set in which these 2 points are contained, and it is less than epsilon by previous. So we are able to find x m and n such that for all n is greater or equal to n, distance between these two is less than epsilon. So clearly this is a Cauchy sequence. And by our assumption, since it is x is complete, so x, we are able to find x such that limit n tend to infinity, xn is equal to x, means it cannot converge outside the this set x. So now second part we try to show, if we take arbitrary section of each fn, means n vary from 1 to infinity, then this limit point whatever x where xn is converging, this definitely belong to that. How to prove? Suppose if possible this does not belong. So if any element is does not belong in intersection, so obviously it should not belong at least in one set. So we assume there is some positive integer m such that x does not belongs to fm, and it is given fm is closed and it x is not does not belongs to m. So distance between xm and fm is greater than 0. Why? You can see here. Suppose my this set is what? Fm. And we are saying x does not belong to that. And f is closed, so it contains all its limit point, all its limit point. So if you take distance of x from any point of that, it should be definitely greater than 0. If it is not greater than 0, it means either distance is greater than 0 or equal to 0. If it is equal to 0, then that should either belong to that set, either that should be the limit point. But we are saying no, it does not belong to fm, so neither it is belong to that, neither is the limit point. So distance is definitely greater than 0, and we assume this distance is nothing but r. So distance between these x and any point of fm, you say y1, y2, y3, that should be also, this should be either equal to or and greater if you take any y belongs to it. Now since distance between fm and we have taken earlier fm and x, this distance we have taken r. Okay, this is x. So now I'm constructing an open sphere of radius r by 2, of radius r by 2. So definitely this s r by 2x and fm both intersection is what? Disjoint. This is clearly disjoint, means nothing is common. Now if we assume n is greater than m, so by the assumption fn should be the subset of m. This is the decreasing sequence, and this implies xn belongs to fm. Why? Because xn coming from fn, and xn is fn and fn is subset of fm, so xm definitely belongs to xn definitely belongs to fm. And since fm and s r by 2x are disjoint, so this xn cannot belongs to the open sphere of center at center x and radius r by 2. It means we are able to find the term of the sequence xn, which is where n is greater than m and xn does not belong to that. It means x cannot converge to x, because by definition of convergence of sequence, any sequence xn converges to x if you take any so xn, it will converge to x only if you take any open sphere of any radius greater than 0, then this contains infinite sorry, this is x, this is by mistake. Uh, let's I try to make again the picture. So any sequence xn converges to x when, by definition, if you take any open sphere center at x of any radius epsilon. Obviously epsilon should be greater than 0. then this open sphere should contains infinite number of term of that what xn. But here we are able to see if we have take n greater than m, so all xn does not belongs to SR by 2x, means it in that belongs only x1, x2 add to xm. After that term of the sequence, when n is greater than m, means xm plus 1, xm plus 2, all does not belong to that. It means, as by this conclusion, here only finite number of terms belong. But by the definition, it's any hemisphere should contain the infinite number of terms xn. So here, this violates the convergence of sequence. So our assumption is wrong. So x belongs to the arbitrary intersection of. Now, we try to show there only one x belongs to the this arbitrary intersection. Let's suppose if possible y be another point which belongs to arbitrary intersection but is does not equal to x. Since y belongs to the arbitrary intersection, so it belongs for each set by the intersection property. And we know the distance of 2 points is always less than diameter of that set. And here y belongs to Fn, each Fn, and x is also belongs to each Fn because x and y both belong to arbitrary intersection. So it is less or equal to diameter of F for any n, since diameter is always supremum. Now, since d of Fn tending to 0, then as n tending to infinity, so d of Fn this tending to 0, so what become d of xy is tending to 0, means dxy less or equal to 0. But we know that distance by the definition of metric, distance between the 2 points is either greater or equal to 0. So once we have get less or equal to 0 and the greater or equal to 0, so this possible only distance is 0, and by the definition of metric space, distance of 2 points will be 0 if and only if both are same. So x is equal to y. So it means whatever you have assumption y is different, it is basically the same. So it confirms the uniqueness. Next, this is the uh, another important result. Basically, it's the corollary of this that is called the Cantor's nested interval theorem. So what we do, in place of closed set, you just set the closed intervals, because we know if you take ai comma bi, I belong to some n. So in the real line, all the closed intervals are closed set, and interval containing within the previous means a1 comma b1 is superset of a2 comma b2. It means these are the decreasing sequence, and length of the interval approaches to 0. The length of an interval is nothing but bi minus ei, and is tending to 0 as I tending to infinity. So this is the nothing but this is the diameter of ai comma bi, maximum distance. So the diameter of ai comma bi nothing but here mod of bi minus ai, and by assumption is tending to 0. Then by the our previous theorem, this arbitrary intersection, then there is exactly one element contained in all of the intervals, means ai bi where I vary to 1 to infinity, we can get 1 and only 1. So here in the Cantor's intersection theorem, in place of closed set, here taken closed interval, and in place of diameter, here taken the basically the length. This is also diameter of any set, any interval a comma b. So its diameter is nothing but difference of last point and first point. This is the nothing but, and we are taking it some mod because diameter cannot be the negative theorem. So we have finished this theorem. So thank you very much for watching this video. So if you have any doubts, suggestion, comment, it is the most welcome. So thank you very much. Once again, happy independence to all Indian. We are proud of that. So thank you very much.